Let's try our second problem. And with any problem like this, where you have some reaction occurring, they show you some mechanisms, some reactants and products, the most important question to really start with is what's changing? Be very, very rigorous and meticulous with answering the question, what is changing? Because oftentimes you're going to see some pretty complex mechanisms, and it'll seem like it's way over your head. But if you ratchet it back to the basic foundational principles of reactions, you need to understand what is happening in the reaction, what's changing. And here, the only thing that's changing is I'm going from a carbonyl to an alcohol plus this alkyl group. So I'm basically breaking the double bond, adding an alkyl group, and ending up with an alcohol. Now, one thing that's interesting is you'll note, whatever my reagent was, it must have had some group that looks like this. Because you can see that's how it added. There's some compound or some functional group on that 2-carbon that caused it to add there. It's not going to just happen with alkanes, something like that. They're mostly unreactive. They're not really going to do anything. So it's not really going to happen with alkanes. Something else was on there. And so I'm looking for a reagent with that structure, with that general shape. Now, you might recognize that the breaking of the carbonyl, turning it into alcohol plus an alkylated product, is a Grignard reaction. So you could select A with that information. HBr would generally result in a halogenation reaction or acidification, so it could add protons. Phenyl chloride, we'll see that is a halogenating product. Okay? Lithium aluminum hydride is a reducing agent. So none of those are really what I'm looking for. The answer here is going to be A, it's a Grignard reagent. But you'll also notice that B, C, and D all just have the alkane. They just have pentanes. The only one that actually has some structure that resembles what my reagent must have had is A. This Grignard reagent is structured like this. Okay? And on the exam, the correct answer for reaction questions like this is going to be the only plausible one in terms of its structure. Because again, they're not really testing you on super in-depth mechanisms or reagents or reactions. It'll appear that way, but you'll always be able to deduce the correct answer even from just the very basic structure. I've seen questions that are quite easily answerable, even when I had no idea what the reaction was. I had never heard the term before. And they just throw it at you cold, right? They'll tell you, here's the reactants, and they're going to undergo this type of reaction. They'll give you some extra bit of information, like the resulting molecular weight or something like that. And they'll ask you, what reagent must it have been? Well, it's always going to be answerable with the information that you have, okay? And relatively basic logic like this. I know roughly what my reagent has to look like, and the only plausible one is A. Okay, so we can eliminate all the others based on our knowledge of the chemistry. We don't necessarily have to have that super in-depth knowledge of chemistry in order to be able to answer the question. Imines and enamines, I mentioned an imine before. It's where you have a double bond between a carbon and nitrogen. Imines and enamines are tautomers. You can see they vary in the position of this adjacent double bond. And I like to remember enamines because these are ene amines. Alkene, amine, enamine. So you just need to know very basic things about these, that they are tautomers and they can be derived from aldehydes or ketones. with some amines. Okay? So recognize these when you see them, but there isn't any specific chemistry we need to talk about them. Aldol condensations are a specific type of reaction where an enol or an enolate, and we saw that, reacts with a carbonyl and you dehydrate the product. So you're going to end up here with a condensation reaction or a dehydration reaction to form an enone. Okay? Not an enol, which is an alkene alcohol, but an enone, which would be a ketone or aldehyde, potentially. Alkene. Okay? So let's look at and examine how this reaction occurs. I start off with a ketone, and remember my ketone can undergo keto-enol tautomerism, so it'll form an enol. And when the enol is reacted with a carbonyl, again, either an aldehyde or a ketone, it forms this intermediate product. It has the carbonyl, and it has this hydroxyl group. That intermediate will dehydrogenate. You'll pull off an H, pull off an OH, and you end up with an H2O and this alkene. Okay? So let that sink in. Have a sense of what's occurring here. But again, you just need to know these generic basics. What goes in, what comes out. You don't have to know each of the individual mechanistic steps. You don't have to be able to do the electron pushing diagram for these. You don't have to memorize really too much about these. You should just recognize basically what's occurring when you see this. And obviously by the name, you can tell a condensation reaction, we're going to be removing water.
For most students, and maybe you too, the CARS is the hardest section on the MCAT. It may feel like it's one of the few remaining obstacles between you and the medical school of your dreams. But as you try to prepare for the CARS, you find there is a never-ending stream of conflicting tips, strategies, and plans, none of which seem to actually help or show any results. If you feel frustrated, overwhelmed, or lost when it comes to the CARS, if you're looking for a CARS expert who has helped thousands of students achieve their MCAT CARS goals, then you've found your solution. Testing Solutions MCAT CARS Bootcamp. Founded by Nick Zahner, a current medical student at Stanford with a master's degree in philosophy of religion from Harvard, Testing Solutions' approach to the CARS is revolutionary. Testing Solutions CARS Bootcamp provides day-by-day, step-by-step instruction that teaches you the techniques that produce ultra-high MCAT CARS scores. Instead of wasting your time with the needlessly complex filler that other companies try to sell you, Testing Solutions' approach to the CARS is based on the principle of minimum effective dosage. There's no wasted time, just the minimum amount of effort that is required to get you the results you want. With over 500 4.5-star reviews on Amazon, Testing Solutions CARS Bootcamp is the most trusted, proven, and effective CARS course available on the market today. You will have access to Testing Solutions' 180 meticulously designed CARS passages, the largest CARS practice library offered by any MCAT prep company in the country. Our passages are regularly rated by users on Amazon, Reddit, and SDN as the most accurate non-AAMC CARS practice passages available, consistently rated higher than Exam Crackers, the Princeton Review, Kaplan, and Next Step. Unlike some companies who prey on pre-medical student fears by charging outrageous amounts of money for their mediocre at best practice materials and courses, Testing Solutions will always charge a fair price for an amazing product. Because after all, we're not like the other test prep companies. We're aspiring doctors just like you, only a little further down the path. Let us help you do what we've already done. If you're not happy with your CARS Bootcamp for any reason, we offer a 100% money-back guarantee, no questions asked. You've got nothing to lose and the CARS score of your dreams to gain. Don't be one of the people who write us each week saying they wish they had found our MCAT CARS Bootcamp sooner. You don't have to struggle with the CARS any longer. Sign up and get started today.